Good morning, everybody. I remain on SIR-MuCOT Timothy. Today we'll be looking at two topics in mathematics, which is standard form and significant figure. Well, I'll be starting with significant figure, and my aim of doing this is that by the end of this lecture, by the end of this class, you can be able to, solve standard form, solve significant figure, find the significant figure of the standard form, or change any number from its original form to what a standard form. So I'll start with what significant figure. I'll start with significant figure. So what is a significant figure? I would say that a significant figure are those figures or numbers that has tangible counting units. Or let me say, there are those numbers, numbers that has natural counting numbers. I believe that definition is okay. So to explain further what I mean, what I say, just look at this way of giving serial number 001, 002, 003, 004. Now, we all believe that this is 1, 2, 3, 4. But if we change this, like if we mirror this now, we have 100, 200, 300, 400. Now we say it now. The zeros here came before the natural counting numbers, and the zeros here came after the natural counting numbers. Where am I going to? Here you pronounce this, you call this 1, you call this 2, you call this 3, you call this 4. But here it is not the same. You call this 100, you call this 200, you call this 300, you call this 400. Now, here they are not the same thing. The zeros that came before the tangible counting units does not or do not add any meaning to these counting units. It does not add any meaning. But the zeros here add meaning to this counting unit. So with this now, you can be able to imagine what a significant figure is, or what significant figures are. Now let us try something. If you claim these zeros here, it is still 1, 2, 3, 4. But if you claim this one that is here, you find out that you don't have 100, 200, 300, 400 again. What you have is 10, 20, 30, and 40. Claim this one again that is here. You still have 1, 2, 3, 4. Claim this one that is here. Do you see that you don't have 1, 2, you don't have 10, 20, 30, 40 again? Neither do you have 100, 200, 300, 400 again. What you have here is 1, 2, 3, 4, 1, 2, 3, 4. So significant figures matters a lot. The zeros, how we add zeros, matters a lot. And there are many other examples, but this is the one I wish to work with. Also, there are some rules I would like to put down on the board that will help us to be able to find the significant figure of a number. Change a number from its original form to what is significant, to the number of significant figure they ask us to do it, to change it to. So some of the rules, I'll call them rules, if you like call them laws, if you like call them guidelines. Let me just say guidelines to sig fig. Guidelines to what? Significant figure. So number one, sorry about this. Number one, all leading zeros are not significant figures. All the leading zeros are not what? Significant figures. just as we saw in that serial number stuff, 0001, 0002, and 10002000. We found out that these two things are not the same and they can never be the same. This is 1, this is 2, this is 1000, this is 2000. So now you see that this first guideline says that all leading zeros are not significant what? Figures. So whenever you see something like this, with this guideline, you just know that these zeros here are not what? Significant figures. So now the second one says all non-zero digits are what? Significant figures. All non-zero digits are what? Significant figure. So for us it's not zero, they are what? Significant figure. Even if it's 1000, it is what? A significant figure. So now let's say 0001, 0002, 0003, 0000. Now here, how many significant figures do we have here? None. Because the first guideline said that all leading zeros are not significant what? Figure. And here now, let's assume, okay, let me say 0000, 0010, 0100, 1000, and have 0000, 0001, 0012, 0123, 1234. Now let's take for instance now that we have this number now. All leading zeros are not a significant figure. We remove the leading zero that is here, we still have 0. We still remove this leading zero that is here, we still have 0. We remove the leading zero that is here, we have 1. So we see that here we don't have any significant figure. Here we don't have any significant figure. Here we have what? This significant figure, because guideline number 2 says that all non-zero digits are what? Significant figure. So now there's one significant figure here. So now we'll go back to number 1. We remove the leading zero that is there, we still have 0. We remove the leading zero that is here, we now have what? 1. We're not going to remove here because there is no leading zero here and there's no leading zero here. So there is one significant figure here. If you go back to number 1 and remove the leading zero that is there, you still have what? 0. Remove that leading zero, you see, you don't have any significant what? Figure there. So if you have zeros throughout, there's no significant figure unless you have a number that is not 0. Unless you have a number apart from 0, that is when you now say that I have this so and so significant figure in a given what? Figures, or in a given digit, in a given numbers. So the same thing is applicable here. Remove this, and all that. So now we go over to the third guideline. The third guideline says that all zeros between two non-zero digits are what? Significant figures. Is it that all zeros between two non-zero digits are what? Significant figures? I think this should be number 4. This should be number 4. Number 3 says that is what I want to put here. Number 3. Let me say all trailing zeros. All trailing zeros are what? Significant figures. All trailing zeros are what? Significant figures. What do I mean by all trailing zeros? Let us see that example 001, 002, and 100,200. We find out that here, from number 1, all leading zeros are not significant figure, but number 3 says that all trailing zeros are what? Significant figure. Now, these are the leading zeros. They are not significant figure because they don't add any meaning to these counting numbers. But the other one, all trailing zeros are significant figure. These are the trailing zeros. Okay, let me put this back. These are the trailing what? Zeros. Here is 100, here is 1. Here is 200, here is 2. You see that these zeros that are attached after the counting numbers added meaning to the counting numbers, but this zero that is before the counting numbers do not add any meaning to what? To these numbers. So now this guideline number 3 says that all the trailing zeros are what? Significant figure. That means that when you are asked to find the significant figure of any number, once you hit the first non-zero what? Digit, if there are thousands of zeros, thousands of trailing zeros, they are all what? Significant figure, because it gives meaning, it adds meaning to what? That first non-zero digit. So now the fourth one, the one I claimed, is that all zeros between any two non-zero digits are what? Significant figure. Yes, all the zeros between any two non-zero digits are what? Significant figure. For example, let us say that we have 101, or have 1001, or have 2000, 2,000,100,004. Now, this are significant figure because if you remove this zero here, okay, if you remove this zero here, we're going to have 1, 1. This is 101, and this is what? 11. This is 101, and this is what? 11. They are not the same thing. Meaning that this zero here added something to this digit. Do you understand? It added something to this what? Digit. These two zeros here added something to this digit. If you remove this one, we'll now have what? 11 again, but here is 1001. With there are many what? There are many space. And if you remove all these zeros here, what are you going to have? 214, which is 214. But what we have here is 2,100,004. Right? Yes. But here we have 214. So this is a very nice guideline towards significant figure. So the next one, number 5, says that in a whole number, all the zeros before a decimal point is all the zeros are what? Significant figure. So in a whole number, all the zeros before a decimal point are what? Significant figure. What does it actually mean? For example, let's say 2000. Okay, let's say we have something like 0, 1, 2, 0, 0, 0.46. Now this rule number 5, this guideline number 5 says that these zeros here, actually, they are significant figure, because if you want to call this number now, this is now 12,000, this is 12,000 and here is what? 46. This is not 46. It is what? 46. Now, from what I know, from what I've experienced, is that any number after the decimal point is being called individually. So now, these zeros here actually are what? Significant figures, but this one is not, because it's what? A leading zero. So that is what this fifth guideline tells us, and so these are what I can come up with. If you still have some guidelines that will help know significant figure, please do put it down in the comment box. I would learn it. And if you have any question, or if you feel that these are not sufficient enough, hit me up. I will just learn. Thank you. And we're not going to be solving any example now. Let me finish standard form, then we'll solve the examples together. So the next one is standard form. Standard form. What is a standard form? Or when is a number said to be in a standard form? When is a number said to be in a standard form? What is standard form? All those, all that, yes. Now, when a number is said to be in a standard form, it is expected to be in this, let us say, let me use capital. A multiplied by 10 raised to the power what? M. Now, if it is in this form, just like in my own level and in my own level of knowledge now, if it is in this form, it is in standard form. Now, one might be asking many questions. What is A? What is M? This, that. Actually, I might say that A here, they are numbers. If I say that A are numbers between 0 and 9, am I wrong? Check. Well, you are free to pause the video and check if I'm wrong. Then let's continue. Actually, I am wrong, because in mathematics, anything multiplied by 0 is what? 0. Anything 0 multiplies is what? 0. So that means that there might be a case that here will be what? There might be a case that we might have 0, 1, 2, 3, 4 as a number. And if we want to put this in standard form, we write 0 times 10 raised to the power 1, 2, 3, 4 raised to the power 4. Actually, this is returning what? 0. But this number is not 0. This number is 1, 2, 3, 4, which is 1234. Now, you see that this actually did not work. So, we can now say that to avoid that kind of thing, we can now say that A are numbers between 1 and 10. The number between 1 and 10. By so doing, you've excluded what? The casualties of putting or having zero in your number. So let's proceed. A number is in standard form. Let me use SF for standard form. If written as A multiplied by 10 to the power 10. There are some things I will also Well, let's continue. When we get there, I will let you know. So, and we say where A are digits ranging from 1 to 10, and n and m is an integer. So you see that now. A are digits ranging from 1 to 10, and m is an what? Integer. It doesn't matter if it's a positive integer or negative integer, just know that it is what? It is an integer. Now, for instance, one might be asking, I said that A are digits from 1 to 10. What if they give us minus 2, 3, 4, 5, 6, and say that we should put it in standard form? Actually, it is still the same thing. It is still the same thing. Now, looking for the standard form, you just have to put your negative sign out. If you like, you can put it in what? In a block or chain bracket or parentheses. Anyone you choose can work for you. Now this is 2.3456 times 10 raised to the power what? 4. Now looking at this now, our A here now, is it not ranging from 1 to 10? It's ranging from 1 to 10. Now our negative sign is still there. So that is it. What other thing do I want you to know from this now? So okay, let's continue. So there's something that has been in my brain. Oh, for that they give us 2, 3, 4, 5, 6, and so I should put it in standard form. Put it in standard form, we have 2.3456 times 10 raised to the power 4. Now, I want you to look at this very, very well. Look at this thing here. What do you have? This thing that is here is what we have here, but this has been expressed to one significant figure. When we express it to one significant figure, we have this. Do you understand now? And also, this one that is here is an indices to the power what? 4. So I've been trying to know if standard form can be defined in any way, combining significant figure and indices together. Well, for now, I just figured it out now. If you can define it, I will be highly pleased. Just put it down in the comment box below. I will learn it. But if you cannot, when I get back to my reading hours, I will know if I can do them. So, without wasting much of our time, I would just like us to go to examples. So that's example number 1. Solution to number 1. Now this number 1 now, we are going to change it to one significant figure, two significant figure, then change it back to what? And then express it in a standard form. So to one significant figure, we have what? That it is 1 to one significant figure is just what do we have? 1. Or maybe if you want to approximate, you can actually write 2. Now to 2 sig fig, what do you have? 1, 9. so on and so forth. Now, let us change it to what? Standard form. To its standard form, we'll have what? 1.90300 times 10 raised to the power what? 1, 2, 3, 4, 5, 6 raised to the power 6. That is what in its standard form. And let's go to number 2. Number 2, to 1 sig fig, we have what? 1. To 2 sig fig, we have what? 1, 1, 2. To 3 sig fig, we have what? 1, 2, 0. Now to its standard form, what do we have? We have 1.202000 times 10 raised to the power 6. Now number 3, I have to 1 sig fig, I have what? 4 is what? 0.00004. What the rule number 1 says? All preceding zeros are what? Not significant figure. So this is off. 1 sig fig 4. To 2 sig fig is what? 4, 8. So on and so forth. Now to its standard form, we have what? 4.8 times 10 raised to the power 1, 2, 3, 4, 5. Raised to the power 5. Is this raised to the power 5? No. Because what? This actually is not a whole number, it is what? A decimal. It is in decimal, so we have negative 5. So that when you carry this operation out, you have back what you have here. So now the number 4 is to 1 sig fig, you have what? 7. To 2 sig fig, you have what? 7, 6. Actually, if you want to like round up, you can call this 8, but let me leave it at what? 7. So now to its standard form, we have what? 7.64 times 10 raised to the power what? 1, 2, 3, negative 3. So now that's where we'll be stopping for today. This number 5 and this number 6 is an exercise. Please, I'm open to correction. If you find anything faulty in what I did, you can just correct me and put it down in the comment box below. When I see them, I will learn them, and I will really appreciate people that will do that. Thank you. I remain always SIR-MuCOT Timothy. Have a nice day.